Hello ninth graders. In this video, our topic is about covalent bonding. Recall that valence electrons are the electrons found on the outer energy level, while valency is equal to the number of lone electrons that this element possesses, or is equal to the number of electrons involved in bonding for an atom to achieve the electron configuration of the closest noble gas. And the column or group to which an element belongs is equal to the number of valence electrons of this element. Let's take an example. Elements of column 2 have 2 valence electrons, while elements of column 17 have 7 valence electrons. And an atom becomes stable if its external shell K carries 2 electrons, and this verifies DeWitt rule, or if its external shell L or M carries 8 electrons, and this verifies octet rule. And in this video, we'll cover the following objectives. Prepare your materials to start. Almost everything we see or touch in our daily life is made up of atoms. But these atoms are not always isolated, rather they are transformed into compounds as a result of chemical bonds. Consider these compounds. They are made up of atoms or ions bonded to each other, and the force that maintains atoms or ions together is called chemical bond. And the chemical bond could be covalent or ionic. And covalent bond is either single, double, or triple covalent bonding. And now we are going to discuss the single covalent bonding. Consider this polystick of a hydrogen molecule H2. What is the type of bond between the two hydrogen atoms? How many valence electrons does a hydrogen atom have? It has only one valence electron. Now, how many electrons are needed for hydrogen to achieve the stable electron configuration of helium? Helium has only 2 electrons, so the hydrogen atom needs only 1 electron to achieve the stable electron configuration of the helium inert gas. Consider 2 hydrogen atoms, each having 1 lone electron. Each hydrogen atom will share 1 pair of electrons with the other hydrogen atom to verify their DeWitt, forming a single covalent bond. Do you remember the Lewis dot symbol of hydrogen atom? That's it. Let's identify now how to write the Lewis dot structure of the hydrogen molecule H2. First, we write the Lewis dot symbols of the 2 hydrogen atoms and put the 2 lone electrons opposite to each other. Then, we join these 2 lone electrons. The pair of electrons joining the 2 atoms is called single covalent bond, and it is represented by a dash between the 2 atoms. And the structure formed is called the Lewis dot structure of the hydrogen molecule H2. Now consider a water molecule H2O made up of 1 oxygen atom and 2 hydrogen atoms bonded to each other. What is the type of these 2 bonds? Hydrogen atom has only 1 valence electron on its valence shell, so the valency of hydrogen is 1. Since hydrogen needs only 1 electron to be stable and satisfy DeWitt rule, which is stability with 2 electrons, while oxygen atom has 1, 2, 3, 4, 5, and 6 valence electrons on its valence shell. So the valency of oxygen is 2, since oxygen needs 2 electrons to be stable and satisfy octet rule. So each hydrogen atom will share 1 pair of electrons with the oxygen atom, forming 2 single covalent bonds. Let us write the Lewis dot structure of the water molecule H2O. First, we write the Lewis dot symbols of the oxygen and the two hydrogen atoms in such a way that the lone electrons are put opposite to each other. Then we join these lone electrons. This structure formed is called the Lewis dot structure of water molecule. In this structure, we have two non-bonding pairs of electrons and two bonding pairs of electrons. Now we can apply. Consider the Lewis dot symbols of carbon and hydrogen atoms. In part A, we have to identify the valency of carbon and hydrogen atoms. In part B, we have to explain the bond formation in methane gas CH4. And in C, we have to deduce the Lewis dot structure of CH4. Part A. Carbon atom has 4 electrons in its Lewis dot symbol, then the valency of carbon is 4. Hydrogen has 1 lone electron in its Lewis dot symbol, then the valency of hydrogen is 1. Part B. In explaining the bond formation in CH4, we have to say that the valency of carbon is 4, then carbon needs 4 electrons to become stable and satisfy octet rule. And the valency of hydrogen is 1, then hydrogen needs 1 electron to become stable and satisfy duet rule. Then, in CH4, carbon atom will share 1 pair of electrons with each of the 4 hydrogen atoms, forming 4 single covalent bonds. And here is how to draw the Lewis dot structure of CH4. First, we put the Lewis dot symbols of the carbon and hydrogen atoms in such a way that the lone electrons are put opposite to each other. And then we join the lone electrons, forming 4 single covalent bonds. Keep in mind that single covalent bond is sharing of 1 pair of electrons. This means 2 electrons each coming from 1 atom. As an example, in H2, each hydrogen atom will share with the other hydrogen atom 1 pair of electrons, forming 1 single covalent bond. In CH4, the carbon atom will share 1 pair of electrons with each of the 4 hydrogen atoms, forming 4 single covalent bonds. In H2O, oxygen atom will share 1 pair of electrons with each of the 2 hydrogen atoms, forming 2 single covalent bonds.